Alright, this is a video for geometry assignment 11, finding parts of triangles, so finding an angle or a side in a triangle using your trig ratios. I know this is sort of hard to see. It's not, my print here is not the biggest. First part says find the, and I'm just going to do the odd numbers and let you do the even numbers to try each one to make sure you understand it. First part says find the measure of each indicated angle. I talked a little about in prior stuff and prior videos that this symbol is a theta, and that's what we use to represent angles a lot of the times. We could also say angle A here, but they use that symbol a lot, so just know that that's what we're looking for, is that certain angle. So here it's angle A, here it's angle A, might be angle A on all of them. Down here it's angle B, so on and so on. All we're going to do is every single time, you got to remember a few things. You got to remember your SOHCAHTOA. SOHCAHTOA stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we're going to have to label our triangle first, when we do all that. The other thing that in the notes that you should have seen is you need to know your equation. Your equation every time is going to be the trig name, sine, cosine, or tangent, then the angle, then equals, and then the fraction. Opposite over adjacent, or adjacent over hypotenuse, whatever it is that you're dealing with there. So you've got to remember both those things every single time. First thing I'm going to do, no reason to really pick an angle here. They're telling us which angle to deal with, so I'm going to label the triangle accordingly. That's your opposite leg. Every single time you got to do this. Your hypotenuse is across from the right angle, and then the other side is the adjacent leg. That's the leg that's hooked to the angle that we're dealing with. Got to decide which trig ratio are we using. Are you using sine, cosine, or tangent? The way you decide that is by the information they give you, or maybe the information they don't give you. They don't tell us anything about the opposite leg, and we're not trying to find it, so we're sort of going to get rid of it. So we're dealing with the adjacent leg and the hypotenuse. Which of these deals with adjacent and hypotenuse? It's cosine, so that's what we want. So we set up our equation. Trig name, which is cosine. The angle, we don't know, that's our theta. Equals, then for cosine it's adjacent over hypotenuse. Well, the adjacent this time is 12, and the hypotenuse is 13. So we just write it in that way. That's our equation. When you're looking for an angle, it's sort of easy because the calculator is going to do most of the work for you. And all you're going to do is on your calculator, you're going to hit, since we're looking for an angle, you always got to remember to hit second first. Then you hit your trig ratio, or your trig name that you're looking for or dealing with, cosine, and then we just punch in this fraction, 12 divided by 13. So it looks just like that. You hit equals, and we'll round that off to, we'll say about 23 degrees. So that angle A there, or that theta, is about 23 degrees. So we're going to do exact same thing on number 3. We're dealing with this angle. That's the opposite leg. That's the hypotenuse. This side over here then is the adjacent leg. We're going to set up our equation. Well, we got to decide which trig ratio we're going to use. We really don't care about the opposite leg this time because we're not trying to find it, and they didn't tell it to us. So we're using these two. So we're again using cosine. So we do cosine of theta. That's our angle. Equals adjacent over hypotenuse, so 6 over 9. And we're going to let our calculator do all that work again. You hit second cosine, because we're looking for the angle this time. 6 divided by 9. And it tells us about 48.2. We'll just say about 48 degrees. That's close enough. So that's the answer to number 3. If you round these off, I'm sorry, it said round them off to the nearest tenth, didn't it? So this one should have been 22.6. I should read the directions. And this one should have been 48.2 degrees. Because we're going out one place. It tells us round it to the nearest tenth in the directions. Number 5, same idea in number 5. We're dealing with this angle. That's your opposite leg. That's your hypotenuse. Across from the right angle. And that means this other side's got to be the adjacent leg. Figure out which trig ratio we're dealing with. We care about the adjacent. We care about the opposite. We really don't care about the hypotenuse this time. The trig ratio that deals with opposite and adjacent is tangent. So we do the tangent of our angle. That's theta. And it could be angle B, whatever. It doesn't, whatever it is. And then remember that tangent is opposite over adjacent. So opposite, which is 7.7, over the adjacent, which is 14. We take our calculator. We hit second tangent because we're looking for the angle. 7.7 divided by 14. And we get 28.8. So angle B right there is about 28.8 degrees. For all these problems, you're doing the same thing over and over and over again, just figuring out what you're dealing with, labeling the triangle, figuring out what you're dealing with, and setting up an equation that's going to help you find what you're looking for. This time we're looking for this angle, so that's the opposite. Side across from the right angle is the hypotenuse. And this other side is the adjacent leg. We really don't care about the opposite side this time. So we're dealing with hypotenuse and adjacent. Which again, if we go to SOHCAHTOA, the ca part is the cosine and it's adjacent over hypotenuse. So that's what we're using. So cosine. Our angle is our theta. And again, you could put angle B in there. Doesn't matter. It's the same thing. Equals. It's the CAH part. Cosine is adjacent over hypotenuse. So 4.4 over 11. We take our calculator. We're looking for the angle. So I hit second cosine and I just punch in that fraction, 4.4 divided by 11, and I get 66.4. So number 7, that angle is 66.4 degrees. And then you got to label the triangle. That's your opposite leg. That's your hypotenuse. This is your adjacent leg. We're trying to find the adjacent and we're trying to find the hypotenuse, but we can only find them one at a time. So you got to pick one. I'm going to pick the hypotenuse first. So I'm going to make this hypotenuse X. I know this side and I know the hypotenuse. I'm not worried about the adjacent right now. We'll come back to it and find it here in a minute. But right now we're just dealing with opposite and hypotenuse. Well, the trig ratio that deals with opposite and hypotenuse is the sine. That's the SO part. Sine is opposite over hypotenuse. So when we set up our equation, just like we were doing We do the sine, do our angle, 62, equals 22.6 over our hypotenuse, which is x. We grab our calculator and we find the sine of 62. Comes out to be 0.8829. Put that over 1. On the other side, we still got 22.6 over x. We're going to cross multiply. We get 0.8829 times x equals 22.6. And if you can find a way to shorten this up because you see the patterns and stuff, then go ahead and do it as long as you're getting the right answer. I don't care. We're going to divide both sides by that 0.8829. So 22.6 divided by 0.8829, and we come up with about 25.6. So this hypotenuse is about 25.6. So now we found two of the sides. Now what we got to do is there's a couple different ways we could do this. We go back and we're going to find the adjacent leg over here. And we could use Pythagorean's theorem. So you could set up, this is what we don't know, we'll call it y this time. We could say y squared plus the other leg, which is 22.6 squared, equals the hypotenuse that we found, which was 25.6 squared. That's using Pythagorean's theorem. You could solve it that way. The other thing you could do is you could set up another trig ratio like we did here, or equation with the trig ratios, and solve it that way. So let's say this time, if I don't care about the hypotenuse, if I wanted to find that opposite leg or the adjacent leg, I already know the opposite. Well, the opposite and adjacent, that's the tangent part, the TOA part of SOHCAHTOA. So we'd set up tangent of our angle, which is 62 degrees, equals the opposite, which is 22.6, over the adjacent, which is y. And we do the same thing there. I'm going to do this one. You could do this, use Pythagorean's theorem if you like it better. I'm going to hit tangent 62 equals, comes out to be 1.8807, and that still equals 22.6 over y. Put a 1 underneath that. You cross multiply and solve, and I'm just going to do this a little bit in my head here. So we cross multiply this way, then cross multiply this way, so then you end up with 22.6 divided by 1.8807, and I end up with about 12.0. So this adjacent side over here is about 12.0. We found that. We found this. We found this other angle. Those are the three parts that we were looking for. Again, if I did Pythagorean's theorem, if I punched this into my calculator, remembering back to doing Pythagorean's theorem, it's going to be 25.6 squared, and then you're going to subtract off this. So I'm just going to say minus 22.6 squared, and then we got to take the square root of that. So second square root, 144.6, and I end up with 12.024, so 12.0. You get the same answer either way. I'm going to let you try 19. I'm not going to do it. I will do 21. It says you are launching a model rocket, and actually I'm just going to set it up for you and then you can solve it. You are launching a model rocket and want to figure out how, I'm sure it should say how high it goes in the air. You stand 100 feet from the launching pad and measure the angle of elevation to the highest point is 77 degrees. How high was the rocket at its highest point? So you're standing here. The launch pad for the rocket is over here somewhere, 100 feet away. The rocket goes up in the air, and the angle of elevation is the angle that you measure using whatever it is that you use to measure, going up right there. So that's 77 degrees. Notice we have a triangle here. Hopefully your rocket went straight up, so that's a right angle. And we want to figure out how high up the rocket went. Well, that's this side over here, so we're going to make it X. This is the kind of problem that we're going to do a lot more on the next assignment, where you actually have to draw the picture. Doesn't have to be anything spectacular, but you draw the picture and set it up from that. You're going to label this triangle. We're dealing with this 77-degree angle. That's probably the one we want to deal with because it's the one that we know. That's your opposite leg. That's your hypotenuse. This over here is your adjacent leg. The two we care about this time is we care about opposite, and we know the adjacent, so those are the ones that we want to use. Well, the trig ratio that deals with opposite and adjacent, that's the toe apart. That's tangent. So when we set up our equation, it's tangent of our angle equals opposite over adjacent. So x over 100. And I'm going to leave you to solve it from there. Remember, you're just going to find the tangent of 77 on your calculator, put it over 1, cross multiply and solve, and that's going to tell you how many feet your rocket went up in the air.